Hello everyone! Today I am going to talk about such a rare earth metal as lutetium. Lutetium is the last element in the lanthanide series of rare earth metals we have become quite familiar with, and that is why it has some unique properties. The elements belonging to this series are arranged in a specific order, in accordance with which the atomic radius of elements decreases from left to right. Lutetium has got the smallest atomic radius, which is why it's got the highest density, hardness and melting point among all the lanthanides. This property is called lanthanide contraction. Anyway, let's not talk about the boring stuff anymore and let us take a look at the metallic lutetium, which when pure looks exactly like other lanthanides, such as erbium or terbium. By the way, this element was discovered by 3 different scientists from different countries. However, this element was named by a French chemist. As was customary back then, he named it after his home city, Paris. He named it after its Latin name, which is lutetium. Chemical properties of lutetium are very similar to those of other lanthanide metals. That is why it is very hard to separate it from terbium, for instance. That is the very reason why its market price is so high, roughly $10 for 1 gram, which makes it just 4 times less expensive than gold. It's okay if you don't know chemical properties of rare earth metals, because they are very similar, with the only exception of europium. Lutetium dissolves well in acids, forming lutetium chloride. In contrast to other colored lanthanide compounds, lutetium compounds are colorless. That is why this metal was discovered only in 1907. Actually, you might be surprised to learn that lutetium can be ground against a grinding wheel, and it can form bright sparkles from bits of this metal, which burn up beautifully, forming lutetium oxide. Speaking of this metal's applications, pure lutetium is added to chromium alloys to increase their density. Lutetium is also added to alloys of iron and aluminum to produce strong magnets, used in aerospace engineering. Lutetium oxide has a relatively narrow range of applications in nuclear technology. It's great for making detectors, especially if its crystals contain cerium, which triggers activation. Such crystals are usually used in positron emission tomography. Numerous clusters of such crystals are used there. Such crystals start emitting faint light when irradiated with gamma rays, which are formed as a result of annihilation of electrons and positrons inside the patient's body upon the decay of some isotopes, for instance, such as fluoride-18. Faint flashes of light are boosted by the detectors, thus creating 3D images of the patient's body, which can show any irregularities, such as cancerous tumors. In nature, lutetium consists of 2 isotopes. The first one is a stable isotope lutetium-175, which makes up the major part, and the other isotope is a radioactive lutetium-176, with an enormously long half-life. It is noteworthy that when a precise dosimeter with an open cap is put next to bits of lutetium, radiation increases by 4 times, which is quite unusual. That happens because pure lutetium extracted from naturally occurring minerals contains radioactive isotopes. There is no need to worry. The same thing is in the case with many metals. For instance, fertilizers containing potassium chloride emit radiation as well, because naturally occurring potassium contains an isotope, potassium-14, but such radiation dose doesn't exceed safe exposure limits, unless you live in a fertilizer store facility. However, there are artificially created isotopes too. One of them is lutetium-177. It is obtained when enriched lutetium-176 is irradiated in a neutron trap. Such an isotope is also obtained in Russia, for instance in IRT-2000 nuclear reactors. The thing is, an isotope of lutetium can be bound with a molecule which effectively destroys cancer cells, and is called DOTA, not to be confused with the video game. Along with radionuclide, the medicine can target cancer cells thanks to the peptide receptors, destroying them with gamma radiation, without damaging neighboring healthy cells. Such a treatment method has begun to be widely used for treating prostate cancer and other cancerous tumors. To sum up, we can say that lutetium is a quite expensive and unusual metal, the range of applications of which